Hello again and welcome guys to G Squared, where excellence is epitomized. I'm Gilly Gills here to simplify things for you. Now today we want to look at writing the chemical formulae of a substance using the swapping the charge method. Now if you're a chemistry student, you must be able to write the formulae of substances, and there are a number of ways to do it. As a matter of fact, this is a part of a 6-part series, and you can find the link for the other videos below. So I'm going to show you today how to write the formulae of a substance by swapping the charges. So as you can see on the board, you have aluminium 3 plus and you have oxygen 2 minus, or the oxide ion. So you have the aluminum ion and you have the oxide ion. Now all I'm going to be doing really is swapping the charges. That's all I'm going to be doing. Just swapping the charges really, which is pretty much this. However, here's the problem. Most students don't know where these two numbers come from, the 3 plus and the 2 minus. Let me just show you where I get these numbers from so you can understand it and you can reproduce it in your own work. Alright, so first of all, aluminum is the 13th element in the periodic table. Oxygen is the 8th element in the periodic table. It means therefore that the electronic configuration of aluminum is 283 and that of oxygen is 26. Alright, so clearly you can see there that aluminum is a metal and oxygen is a non-metal. Right, which means that aluminum will really give up its valence electrons to become neutral, and oxygen will gain just enough electrons to have a full outer shell, which really is 8 electrons on the outer shell. Alright? So, if I take the neutral atom, if I take aluminum with the 13 electrons, because if its electronic configuration is 283, it means that its proton number is 13. How did I get 13? I added up 8 plus 2, 10 plus 3, 13. Now, if the proton number is 13, then the electron number is 13 as well. So, if I want to calculate the charge of aluminum when it has 13 protons and 13 electrons, all I need to do is subtract the electron number from the proton number. Okay? And 13 minus 13 is 0. I can do the same thing for oxygen. Oxygen is the 8th element. Its electronic configuration is 2, 6. And when I add up 2 plus 6, I get 8, which means that it has 8 protons. Now, remember, if it has 8 protons, it has 8 electrons as well. So 8 from 8 is 0. It means that aluminium, the atom, has a charge of 0, and oxygen, the atom, has a charge of 0 as well. But when they bond, the aluminum gives up these 3 electrons, and oxygen gains 2. Remember, it only needs enough so that this 6 becomes 8. And 6 plus 2 is 8. We all know that. Alright, so the aluminum gives up its 3. Now, if it gives up those 3 electrons, it now has none on this shell. So its new electronic configuration is 2, 8, as you can see there. Now, the oxygen, when it gains 2 more electrons, its new electronic configuration is 2, 8 as well. Wow, that's strange. But anyway, it's true. So these two elements have the same, or these two species have the same now electronic configurations. Now let us now work out the charge again. Remember I said you can work out the charge by subtracting the number of electrons from the number of protons. So let's do that. For aluminium, it still has 13 protons. We did not do anything to the protons. All we did was just remove the 3 electrons. We didn't do anything to the proton. So the proton number remains as 13. Now, how many electrons does it have? 2 plus 8, that's 10. So it now has 10 electrons. So 10 from 13 is 3. And that's a positive 3 actually. The mathematician would say plus 3, but because we are chemistry students and we're writing the charge, we say 3 plus. And that is where this 3 plus comes from right there. So that's where that 3 plus comes from. Now let us find out now how we get that 2 minus. The oxygen now has an electronic configuration of 2, 8 because it gained 2 more electrons. So the proton number remains the same. We didn't do anything to the protons. The proton numbers remain the same. Alright, so it's still 8 protons, and now it has 10 electrons. So 8 minus 10 is minus 2, ding ding ding. So we don't write minus 2 because, you know, that is something specific in chemistry. We write 2 minus, which is the charge of the species. So that is where this 2 minus comes from. It comes from the fact that the number of protons is less than the number of electrons. Hence 2 minus. So now you see where those numbers come from. Let's just write the formula of this species. Right? So all we're doing is swapping these charges. We're swapping the 2 minus with the 3 plus. Now note here, when I'm swapping, I am not carrying over the charges themselves. I'm not carrying over the positive, and I'm not carrying over the negative. All I'm doing is carrying over the numbers. So what I get from that is this. Al2O3. And that here is the formula of aluminium oxide. And there you have it, swapping the charges. So that's how you swap the charges to write the formula of a species. It's as easy as 1, 2, 3, A, B, C, you know. So I hope you find this helpful, and I hope you'll practice it and use it in your studies, and you will become successful from this video. You can write any comments below in the comment section. Please feel free to like, share, and subscribe to my channel, G Squared, where excellence is epitomized. See you next time.